Sample 18, a 200 millimeter diameter pipeline with friction factor 0.03, 150 meters long discharges a 75 mm diameter water jet into the atmosphere at a point which is 75 meters below the water surface at intake. The entrance to the pipe is re-entrant with given K sub E 0.9 if not 0.8, remember, and the nozzle loss coefficient is 0.045. This is 1 over C sub V square minus 1 of the velocity head in the nozzle, so it is 0.045. Find the flow rate and the pressure head at the base of the nozzle. So this is the situation to help us analyze it. So this is 75 meters. And we'll call the velocity at the nozzle tip as V sub n. So if we write energy equation between the liquid surface here, water surface here, and the tip of the nozzle, selecting the datum at the nozzle level, so we have velocity head 0, pressure head 0, elevation head h equals velocity head at the nozzle, pressure head at the nozzle tip 0, elevation head at the nozzle 0, then head loss between this point and the nozzle tip. So this is the equation, and the head loss consists of friction, entrance, then head loss in the nozzle, which is 0.045 of the velocity head of the nozzle. So head equals velocity head at the nozzle plus the head loss, which is FL over D plus K entrance, which are function of the velocity in the pipe, so V sub square over 2G. But the head loss at the nozzle is coefficient, loss coefficient of nozzle. This is quantity 1 over C sub V square minus 1. It may be C sub V that is given, coefficient of velocity. But in this case, it is 0.045 of the velocity head of the nozzle tip. So substituting V sub n square over 2G plus 0.03 times 150 length of pipe over diameter 0.2 plus 0.9 at entrance of the velocity head plus 0.045 of velocity head in the nozzle. So we can combine velocity head in the nozzle. So 1.045 velocity head of the nozzle, then of the jet, then this is 23.4 of the velocity head in the pipe. Now for the relationship between V sub n and V sub b, we use continuity equation. Diameter of the pipe square times V equals diameter of the nozzle tip or jet square Vn. So V is equal to 9 over 64 of Vn. Substitute here. So H is 1.045 of the velocity head of the nozzle plus 23.4 times 9 over 64 V and quantity square over 2G. So expressing H in terms of the velocity head of the nozzle jet. So 75 equals 1.5077 of the velocity head of the nozzle jet. So the velocity of the nozzle, velocity head at the jet is 49.745 meters. So from here we can solve Vn, square root of 19.62 times 49.745. So V sub n is 31.24 meters per second. So we can now compute the discharge, pi over 4, 0.075 square times 31.24. So the discharge is, or the flow rate is 0.1380 cubic meter per second. Now for the pressure head at the base of the nozzle, for the pressure at the base of the nozzle, this pressure at the base of the nozzle. So we write the energy equation between the base of the nozzle and the nozzle tip. The velocity at the base of the nozzle is also this velocity in the pipe. So velocity head at B plus pressure head at B plus elevation head 0 equals velocity head at the nozzle tip, pressure head 0 plus elevation head 0 plus 0.045 of Vn square over 2G, which is the head loss in the nozzle. So again, substituting this Pressure B over gamma W equals 1.025 of Pn square over 2G. So this is 1.045 and this is 9 over 64 quantity square. So combining, this is the result. So pressure pressure at B divided by gamma of water equals 1.025 times this is equal to 49.745. So the pressure at B is 500.2 kilopascals.